From Microbe TV, this is a special immune booster recorded during the American Association of Immunologists conference in Chicago, May 2024, starring Cindy Leifer and Steph Langle, and featuring Rafael Polidoro from Indiana University School of Medicine.
I think we're going to kick it off by asking you, tell us about yourself and when did you first get interested in science?
All right. Well, thank you very much for having me here. It's really a pleasure. It's my first AAI. Awesome. When I first got interested in science, I believe that biology at the time I was growing up, 95 to 2000s, there was a lot of new video games coming out, like a PlayStation was out, and there was a game called Parasite Eve. There's about a mutation in the mitochondria that will pass through females, and because females, they can pass the mitochondria to the progenies. And then I was like, this is super, super cool. So that was when I started getting interested in biology in itself. But another thing that was interesting during school time was I was naturally good at everything except biology. Biology was based in memorization, so I had to sit and study. I loved that challenge. It's just the fact that it was a little harder than usual. So I had one teacher that challenged me to get an A with him. Nobody ever got, and I did not. But I got 86, so B+. He said it was the highest.
Okay.
Yeah, he said it was the highest. So then when I could choose, I was between music. It's, another possibility for creative people. Yeah. I used to play a lot. I still play a little bit.
What do you play?
I play the piano.
Wow.
And guitar. I had to learn 2 instruments.
Oh, that's great.
But it's really fun. And then I got challenged when I wanted to choose. I chose biology just to keep the challenge on.
Sure.
And then I entered the first day I managed to get into undergrads, the college. I wanted to go to a lab. So it's like, I need to find a way. And growing up in the 90s again, influenced by the TV, HIV was a big deal. So I wanted to be the guy that found the vaccine to HIV. So that's how, and I just entered a vaccine lab that did HIV research. Sure. And the researcher was retired. So the lab was someone else, and it was Oscar Bruno Romero, is a Spanish professor there at the University of Minas Gerais in Brazil.
Oh, in Brazil, okay.
Yeah. So then he told me, why HIV? It's like, I went there to talk to someone else, but I talked to him and I said, well, because it kills a lot of people and there's no vaccines and you need to find a way. And it was like, well, if you want to save people, you have to work with malaria. You can work with me. Because every 2 minutes, one child will die of malaria. So this conversation we had already, some people are dying. And I got really interested in parasitic infectious disease since then, especially, malaria is a pretty much pediatric disease because 80% of the deaths are children. So then he used viral vectors against parasitic disease, protozoa and parasitic disease. So it's really exciting. So since then, I worked in vaccines for 9 years.
Oh, that's great.
From that first day on the undergrad until my PhD, I work in vaccines. So it's really exciting, but very different type of immunology because you know the goal, you know what you want. So it's different from basic research. Yeah. So at the end of PhD, I finished early because it was the same research for so long, and I did the vaccine. They have 2 vaccines, one against Toxoplasma gondii, and one against Trypanosoma cruzi, that causes Chagas disease. But I felt like I was lacking knowledge on basic immunology. And my boss, Ricardo Gazinelli, at the time, is a very famous Brazilian researcher. And he got a sabbatical fellowship to go to Harvard School of Public Health. And he wanted to bring someone from the lab. The lab was really big, like more than 30 people. And he called me 7 a.m. And I mean, I'm not used to get calls anytime, but 7 a.m. is special. And he's like, I'm going to Harvard and I need to bring someone. Do you want to come? Because your PhD is kind of done. Yeah. You finish, your paper is published in 2 years. It was really fast. And I look online, where is Harvard? But I knew it was big. I just didn't know where it was. So when I saw Cambridge, I was like, but I do not know UK English. I have trouble getting the accent. Cambridge. And he was like, that's not this Cambridge.
Not the same Cambridge.
He laughed so much. It was awesome. So then I went with him. I did 1 year there. It was very successful. Okay. And because I knew a lot of mouse models of infectious disease, different infectious disease, Judy Lieberman at the Harvard Medical School, she needed someone to run some experiments in granulysin, not king mouse. So mice that have granulysin, they generally don't. And it can cause pores in local estuarine membranes, like microbes. And so then I ran the in vivo experiments for them, and was very successful. It was a very good experiment. It's straightforward. For me, it was bread and butter, but nobody knew how to do it there. So in 1 year, 11 months, I got very productive, and I was part of a Nature Medicine paper with them, I think third author. So it was awesome. So I came back as a postdoc in her lab directly. Mm-hmm. But then I wanted to go for basic immunology. I did not want to keep the track of vaccines. I worked with gamma 9 delta 2 T cells, how they recognize and kill infected red blood cells with Plasmodium, the cause agent of malaria. And that was really, really exciting because there was no malaria research in the lab. So I brought it in and I started trying to reproduce papers from the past in the context of granzyme, that one of the things Judy was really good at the time. Mm-hmm. And I was there when they started the story of the Gazaramine D.
Yep.
So
oh, wow. So you were in a fantastic, exciting time in the lab.
Super exciting time.
But neat that you were able to take what you learned in vaccinology with, parasitic diseases and also bring that to this basic science lab.
Yes.
Great combo.
It was really, really cool. And I actually was interested in testing some of the tools she had with recombinant granzymes and granulysin to vaccine, but she wasn't interested in that part at that time, which makes sense, right?
Sure. Yeah.
So then the gamma 9 delta 2 was exciting enough. So we kept working on this. And then I had to shift labs because fellowship ran out. I came with my fellowship. And I shifted lab to allergy lab. So I did a second postdoc in allergy, completely different stuff. With Patrick Brennan at Harvard Medical School too, Brigham Hospital. And it was really exciting. He was working in NKT cells, as also innate T lymphocytes. And so I learned so much because allergy is totally different from vaccine. It's totally different from gamma 9. The gamma 9 paper came out, the phagocytosis red blood cells paper. And that part, I didn't do that part. I did all the other parts. But gamma deltas get so crazy when they see malaria. I have blood smears that they blast and they become as big as almost a macrophage.
Wow. What?
They really, So I can show you the pictures later.
Wow.
And we didn't put that in the paper. I would love to have, but it's so big already. It is. The Nature Medicine paper too. So or Nature Immunology paper. So it's like gigantic already. But those pictures are super cool. So when I went to Patrick's lab, I had all this T-cell, ex vivo T-cell experience. I started working with him on that and doing CRISPR. It was hot at the time, 2017, 18. So I learned how to do CRISPR in naive cells. In NK cells, I did CRISPR, and I even got shoulder pain for doing clones and so on, which was really, really cool at the time. So, but it was very short. My wife, I met my wife in Boston, and she got a job as assistant professor in Indiana.
Oh, wow. Okay.
So, as someone that wants to support the partner's careers, I just dropped my second postdoc and joined a third one. But I was really skeptical about it. It's like, it's going to be really hard to keep my career on track. As I'm not getting papers from the second postdoc. So as first author, I did get collaboration, but not first author. So I was skeptical. Like, it's time to go to industry, which is also amazing, right? Especially for someone with a vaccine background. But Nathan Schmidt, that's my current boss, he was asking me what my interests are, and he worked in gut microbiota and malaria, which is my current research. And the relationship between gut microbiota and malaria severity is really strong, and it's causal. And it's not pathogenic bacteria dependent. It's regular SPF mice, pathogen-free. And he told me that he worked on that, and it was by Skype at the time. It was not Zoom. 2019, and I told him I don't believe in gut microbiota research. I said that. You see the track, right? My training was so old school, and I said I'll find it association studies. You look at A and look at B, and then you say the A causes B, but it's really hard. And he did the perfect pitch for me to join. He said, "Well, come here, do it with your own hands, and if you prove me wrong that our model is not working because of causality, then I shift my lab into mine.
Oh, wow.
Which is a very scientific attitude, right?
Absolutely.
Absolutely.
And I was so excited. I was like, okay, I'm going to join because I need to show him wrong. And actually, it was the opposite. That was the first experiment. I saw that that the mice, dramatic difference. Like one reaches 60% parasitemia with Plasmodioli malaria and reaches 3 weeks of infections. So it's gigantic area under curve parasitemia. And the other one's just by a mouse from a room A and room B. Same genetic background, everything. And the room B in 2 weeks completely cleared and 10% parasitemia. So shocking. And you just gavage that to each other. Susceptibility is the actual phenotype. So you can cause susceptibility in the resistant mice. And then we use germ-free to show that it's causal.
Sure.
So it's really regular, everyday, normal bacteria can cause what Salmonella was known to do, right? Impact the systemic immunity. So then my research was to figure out why the germinal centers were being disassembled. So they knew that when I arrived. So I tried to find out how the gut is reaching the spleen and what's going on. So getting to the mechanism. So get someone a little bit better trained in immunology. So his lab was more microbiota investigation, so species and looking at the different bulk mechanistic approach, but I wanted to direct it. So I went to the pyre patches and started looking at specific intestinal response and found the Tregs are really high there. So that's what I researched.
So can you say a little bit more about that? So you said the Tregs were high, so that they were higher in the resistant one? Oh, in the susceptible.
Yeah, isn't that interesting? I thought it was a contradiction. They might be responding in the gut and then distracted in the spleen. Oh. But the truth is they are distracted in the gut and then they get distracted in the spleen too. So I actually, this is really exciting because having an audience to say something that's a perspective in immunology, of my opinion, because I come in from Brazil and where you have disease, you need to prevent.
Yeah.
Right. So you growing up, you learn how to boil water to cook and to drink. And so the name of this is hygiene. Hygiene is prevention of disease. Mm-hmm. Attitudes you do to prevent disease.
Right.
And the hygiene hypothesis, it's the opposite.
Right.
It's pretending that in the first world country is clean and then developing country is dirty, which is absolutely not true. New York has 10 rats per person. I don't know, but it's really dirty. You open some cars full of Cheetos and stuff. Like, if you leave a car with food in Brazil, the ants will eat your car. It's just not going to happen.
It's not going to happen. Right.
So I was really angry at the idea that something is called hygiene hypothesis to explain this contradiction between allergies and warm. But the truth is, most of it is pollution. Right? Like allergens. You have way more allergens in cities and industrialized places than not, because São Paulo has allergies like crazy too, and it's in Brazil. So obviously there is actual data showing worms distracting the immune system, so the Th2 gets overwhelmed in the intestine or the lungs and doesn't help you to get asthma. But that is, again, what I'm calling immune distraction. Yeah. It's a much better way to say than hygiene hypothesis.
I see, the distraction
because, because it's literally your immune system is responding to two things at the same time, and sometimes they converge, sometimes they antagonize. In my case, they converge. What happens is you are tolerogenic to your gut to begin with, the susceptible mouse. So they love their neighbors, like, oh, they're my good bacteria, I love them so much. And then when malaria kicks in, the gut barrier is destroyed, and that was known in humans, but we're also showing that in mice through endothelial damage and TNF, IL-1. And so the gut barrier is destroyed. And bacteria, there's a saying in Brazil, that's why did the dog enter the church? And some people say because they want to pray, and it's not true. They enter because the door is open. They don't know religion. So the bacteria comes in and they're SPF. So they really don't know how to infect your blood. So they just transiently. So transient bacteriemia is something that you can find in the literature of children with malaria. And almost every ICU disease has it too. So they come in, and we show that through different mechanisms. And they arrive in the spleen as drainage. And then they do exactly what they do in the intestines. They tolerate. So now malaria has tolerogenic tendencies. They manipulate the immune system to cause disruption already. So then you just synergize the tolerance and it'll pass a certain threshold and shut down the germinal center. So you have a horrible antibody response, parasite escape. And then that's how they're just synergizing Tregs from one thing with the TR1s, probably from malaria. That's how my model is going.
Wow. So do you think you can use that knowledge to try and help people fight malaria?
Absolutely.
So what would you do?
Oh, this is my research. I'm now in the market to try and get my own lab. Yeah. So I thought, because Nathan's research is focused on the gut microbiota composition, so he cares of species and what's going on. Mine, I thought, what can I bring to my own lab? I started using a translational approach with a gut barrier drug for celiac disease called larazotide acetate. And it just helped their paracellular junctions to stay up by countering zonulin, which is a factor, amplifies this damage. It's like when the epithelial layer starts peeling, it peels until the end through zonulin, just like self-producing and self-recognizing. Larazotide blocks that. So then the drug, it's good for celiac disease, but also good for malaria. So after 6 days post-infection, the phenotype's already up, Tregs are already up. But I just stopped gut barrier. So like stop bacteria from coming in or their products, or help healing the gut. And peristemia goes down, mortality goes down 30%. Their health, their skin look good. And it's not antimalarial. It's a peptide. So it's digested in the intestine likely 100%. And it's completely safe, even in children. They did clinical trial with children with COVID. Completely safe, and it's a gut barrier protective drug. So imagine you arrive a kid in ICU, and instead of really giving only IV antibiotics, which is what they always do, right, vancomycin or other, you also give orally. Yeah. You get rid of the PAMPs and DEMPs, because bacteria doesn't need to be alive to cause your recognition in the body. And we measure LPS binding protein levels in the serum. So they're really causing, this immune system is seeing them on top of the seeing malaria. So just stop that. And so that's the research I want to do. I want to see if other diseases and other models.
Well, that was my next question, because we know children in high pathogen burden areas, they have enteropathies, enteric enteropathies. And so rotavirus vaccines don't tend to work as well in those areas because disruption of the gut, potentially zonulin is affecting the ability of that bacteria to become systemic. So do you think that this peptide could also be used to, not in an ICU situation, but in, a standard of care, or when co-giving an oral vaccine where it relies on the gut responsiveness?
Yeah, absolutely. I absolutely believe that it would be, because what happens is we tested all sorts of regimens. One was giving from the beginning, and the other ones was giving after, because of course the kid needs to be sick for you to treat. Yeah. So there are most treatments that start when the mice is still uninfected. I don't like, but I still have to test, and it doesn't work. And the clinical trial for zonulin and for larazotide reached phase 3 and failed. And at the time, I said to my boss, to Nathan, I said, look, I believe I know why it failed. It's just because you had to take the pill and then be exposed to gluten after. And my results show that doesn't work, because zonulin is self-produced. It's a negative feedback loop. So then if you block it, it just produces more. Oh, wow. Right? I mean, that's my guess. I didn't test it because
can they measure zonulin in feces? How,
you can measure. Okay. Yeah, you can do flush in the small intestine. Probably in the feces. I never
did they do that? I'm just curious.
I think the company did, but they shut down the clinical trial when my grants were under review. Oh. So then all reviewers knew, because it was translational study section, and they destroyed the drugs. It's not going to fly, and it's true. It's not going to fly for that purpose. But then I might be able to apply for a different mechanism and see if I can rescue the drug for different sets of pathogenesis or even vaccines. Sure. This is really what I'm interested in.
Oh, that's very exciting. Yeah. And so Nathan, your current advisor, PI, did you have that conversation after you demonstrated, in fact, it is the microbes causing your phenotype? Did you have to revisit that conversation?
No.
I don't have to change my lab now because I convinced you.
No, we never did that. That's a good idea. He knows. I got super excited when I saw it, because it's such striking phenotypes that are natural. Right? It's not like a knockout mice. It's just regular mice from barrier rooms. You just buy from Kingston room 783, Kingston room 63, and they're completely different. And that's really, really impressive. But it has challenges, right? Because like during the pandemic, Taconic closed a whole barrier facility because it was not selling a lot of mice, so they just shut down the one I was using.
Oh.
And I lost the resistant phenotype for a while, and I was it takes few months, and then I got out of visa. One of the struggles of being a foreigner. And my visa shut down during lockdown, so my passport expired. So then I couldn't renew the passport, and the visa also got expired because without the passport number you can't submit. So then I stayed 4 months out of job, 4 months out of Teconic. So it's just little struggles to finish the project. I stumped on the Treg result in my third experiment, but I still didn't finish publishing this. It's now about to be published. But it took much longer because, have the pandemic and other struggles on top of it. And microbiota research just has this magic. Suddenly the phenotype is changing, and it's because it's spring or something, because we buy from the vendors. So we're trying to establish in-house germ-free colonized, just fecal material from the Charles Weaver or from the Teconic.
And limit that variability.
And limit the variability, because it's been really, it's something I don't want to keep waiting 4 months when I lose the phenotype to find another room that has the same.
Right.
So you're going more towards translational work, but is somebody trying to figure out what the actual bugs are, or is there no specific bug?
I actually did a lot of sequencing, and that part, because it's really Nathan's main chief. They're mostly bacteria that induces tolerance to colitis. So the trade-off is pretty much what Hygiene hypothesis was about. The trade-off is, like right now, if you go to India, they would tell you don't drink the water, the tap water, just to get your own bottles, because you're going to have diarrhea. But you have like 1 billion people there drinking it without diarrhea, right? So they have bacteria tendencies to have more bacteroides or bacteria that induce IL-10. Like bacteroides can't colonize mice without IL-10 receptors, for example. So it's just, they need that to establish. So I believe there's a trade-off between the gut protective tolerogenic response, a healthy gut we call. It's good for you until you get malaria, for example, and then it now not necessarily is good for you if it reaches severity. But it's protective if you don't reach severity, because you're less symptomatic. Like Tregs just hold off a little bit the symptoms. Probably it's beneficial until you need a germinal center, very high quality antibodies. And I do believe this is really one of the reasons why there's so much problem if as a type switch, like Myron Pepper's research showing that stay in IgM, and it's still protective, but it's not just perfect protection, but you have repeated exposures until that actually becomes high affinity.
Right.
And I do believe it's just this interference that keeps happening with their own environment. And vaccines, going back to vaccines, something I want to revisit eventually, now that I know immunology much more, would be precisely that. Is it possible to increase vaccine efficacy by interventions in giving the vaccine shot? It causes fever. In the little rare events, they say diarrhea, like up to 5 to 15% people will have diarrhea. So I believe this TNF fever people have, muscle pain, might be causing transient bacteremia too. And what if that's impacting? Because like schistosomiasis vaccine in American healthy adults was amazing. And then they went to Brazil to deploy it, and it was really low efficacy, and then nobody knew how to explain. And I wonder if the gut microbiota is doing something added to it, that you could just give a pill with a peptide that's cheap and safe and increase efficacy. But right now, because the grants flunk, I'm trying other gut barrier protection and looking at the mechanism. So it's a really exciting research plan. I hope I can investigate that.
That's great.
I hope so too.
I think, me too. I think your science and your story tells us really a story of persistence, persisting through multiple challenges and trying to get your science back on track after COVID. I think it's a good story to tell, so that those who are going through similar, struggles, like persist, and you'll get there.
Yeah.
Yeah.
Is there anything else that you wanted to mention before we close up here?
Yeah.
Yeah. Well, we can talk a little bit about the DEI, right? I'm Latino and I'm African American descent. I'm actually indigenous descent too, so I have indigenous people in my family. And as a foreigner and coming from incredibly poverty background, I didn't know what universities were until the last year of high school. And someone told me, and it's like, I'm going to apply for this university. And I said, what? I didn't really know. Nobody in my family ever did. So I thought all the struggles. So then when I got in, I felt really awkward. I didn't belong. So I have lots of initiatives in Boston at the time. I participate in Brazilian researchers and university students in Boston. It's just a little rendezvous we have, meeting with food and talks. To just give hugs. We need hugs. Arriving in the US and people are so, distant sometimes.
Oh, yeah.
So we see each other and it's really, really nice. And now I'm trying to work with the Center for Excellence in School of Medicine in Indiana, try to establish some belonging programs because, inclusion, diversity is fantastic and you have to increase frequency of people of color and minority backgrounds. This is one thing, and especially in leadership positions. But I think belonging for the daily life of a person that just arrived and feels different, doesn't feel included. And everybody's talking about baseball. I know nothing of baseball. So just what do I say?
Yeah. And then if they talk about football, you get the wrong sport. Right? You're like, wait, what?
What football you're talking about? Is it actual football or American football? Yeah, so all those things. So you do, I think it's really cool trying to start looking for belonging. It's the next step over because the initiatives of inclusion are already ongoing and they will bear fruit soon. But I think belonging, it's just daily based. Sometimes you're feeling down, just want to vent. And it's really good to have someone and some place you feel safe to do so with food and hugs.
Those are two key things. Yeah, absolutely. Well, good. Oh, I think that's excellent.
Yeah.
And I think that your story, I think, is really good. So if you had any advice for trainees, what would you...
Yeah, especially those from foreign backgrounds, right, who might have experienced the same things you did.
Yeah.
Do you have words of wisdom?
Yeah, my wisdom would be persistence is definitely for everybody in science. So every trainee should persist because the struggles is real. Even people that look like seemingly with a perfect career, linear career, amazing papers, and those people are also struggling. Don't worry, the struggle is you. I would say just try and find allies everywhere you can. There are allies everywhere you can imagine. There might be stump in a lab that's abusive. You might be stumped with people that aren't helpful or trying to feel unease. Just look a little further, look in the next lab or just talk to the generally people that are involved with students are really, really nice. So the chief of the program student, just ask for a coffee and talk to them about it and they will connect with people, just reach out. I think this was what really helpful for me. Just inside every institute, there are many, many people that are fantastic and really nice allies. They're not going to put their body in front of you, but they will help you manage your own feelings and stressful emotions because they will come nonstop. When your project's going to start getting bad, it's really hard to vent with your own lab or with your own boss. So then you go to somewhere else. And so find that place. It's a fantastic resource. And then when you come back, you can talk about it better. So this is one of my advices for...
It's great advice.
Mm-hmm. Excellent. Wonderful. Well, thank you for joining us. This has been really lovely.
Thank you. I love the podcast. It's such an honor to be here.
Absolutely. Great.
We're excited to have you.
Yeah.
That's a special episode of Immune, an immune booster. If you have questions or comments, please send them to immune@microbe.tv. And if you enjoy our work, please consider supporting the science shows of Microbe TV. Go to microbe.tv/contribute. Microbe TV is a 501c3, so your donations are U.S. federal tax deductible. Our guest today is from Indiana University School of Medicine, Rafael Polidoro. Cindy Leifer is at Cornell University, at Cindy Leifer on X. Steph Langle is at Case Western Reserve University, at Stephanie Langle on X. Music on Immune Boosters is by Tatami. Thanks for listening to Immune, the podcast that's infectious.